Dark web, the hidden part of the internet. It definitely has more extraordinary things than the normal web we browse daily. It's also a digital home to criminals, a place for people to sell and buy literally anything. In other words, it's a place on the internet where most of the illegal activities takes place. But you already know all this. One thing you may not know is how this dark web works. Are you really anonymous while using this dark web? Or is there a way someone can figure out your identity even on the dark web? Dark web works on the onion routing protocol, so you can't access the dark web using just any browser. It can only be accessed by an open source software known as Tor, which stands for the onion routing and implements the onion routing protocol. Now let's talk about this onion routing protocol and how it works. Let's say you want to visit a website on the dark web. Your request is split up into packets, and these packets need to traverse through some intermediate nodes before they reach the server of visitme.onion. Well, that's how the normal World Wide Web also works like. But what's different here in onion routing is that before your request leaves your browser, it is encrypted with n different keys. N here is the number of intermediate nodes that your request will pass through before reaching the web server. Usually, there are at least 3 nodes in between you and the server. So let's say the value of n here is 3, which means there are 3 nodes between you and the server of visitme.onion. For each node, you share a unique key and you encrypt your message with it. Let's say K1 is a symmetric key shared by you and node 1. K2 is another symmetric key shared by you and node 2. And similarly, K3 is shared by you and node 3. Your request is first encrypted with K3 and then K2 and then K1. It is then finally forwarded to the onion network, and the node 1 first receives your request. Since node 1 has the key K1, it decrypts the message. Notice that even after decrypting the message here, the message is still encrypted with 2 layers, that is K2 and K3. So node 1 will know nothing about the request, except from where it is coming and to where it needs to forward it. It then forwards this request to node 2. Node 2 now decrypts it with the key K2 that it has. And you can see that there is still one more layer of encryption even after node 2 is done decrypting. Finally, node 2 now forwards the request to node 3, which then uses K3 to decrypt the request. And now the request is fully decrypted. From node 3, the message is then forwarded to the web server of visitme.onion. So this is how the onion routing works in a nutshell. It works on layers of encryption, making it hard for anyone in the network to track anyone else. In other words, it provides 2 things. Number 1, confidentiality. That is, you don't know who is making a request to what website. And number 2, encryption. Your data while using Tor is encrypted, so no third parties will be able to read it. But is this completely foolproof? Let's go back again and figure out. When your request is first received by node 1, notice here that node 1 knows where you are because you're directly sending this request to node 1, so it knows your IP address. So even though node 1 cannot read your request, it still knows your identity. So there is no confidentiality between you and node 1, which we call as the entry node. However, once node 1 forwards the request to node 2 after decrypting one layer, node 2 has no idea who the real sender of this request is because it is receiving this request from node 1, who is not the real sender. It also cannot read your request because your request is still encrypted. So both confidentiality and encryption are preserved here at node 2. We call node 2 as the middle node. Then node 2 decrypts one layer and sends the request to node 3. Now node 3 can use its key to decrypt the final layer of this request. And now node 3 has the request without any layer of encryption. So node 3 can read your request. It also knows where this request is actually being headed to. However, this problem can be avoided if the website you're visiting uses HTTPS. Because if the website is using HTTPS, even after node 3 decrypts the final layer of encryption, the request is still encrypted with TLS. So it can only be decrypted at the web server. So let's sum all this up. The entry node knows the origin of your request, so there is no anonymity here because it can log your IP address and figure out your identity. The middle node do not know anything. They do not know the origin of the request, they do not know the destination, and they also don't know what's written inside the request. So there is no threat with the middle node. On the other hand, the exit node does know the destination website of this request. And if the website is not using HTTPS, the exit node can also read what's written inside the request. If anyone is monitoring both the entry node and the exit node in your circuit, they may be able to figure out your identity, which includes your IP address and what onion link you are trying to access. One way to overcome this issue is to use Tor over VPN. You first connect to your VPN and then start using Tor. By doing so, your request is first headed to the VPN server, and then it is forwarded to the entry node of your circuit. So the entry node does not see your actual IP address. Instead, it sees the IP address of your VPN server. But even here, your VPN can actually see your IP address. It knows that you're browsing the dark web. So, do you trust your VPN? There's really no foolproof way of accessing dark web securely and anonymously. But using Tor over VPN is definitely a better option than using Tor without a VPN. Also, if you don't trust your VPN service, you can create a VPN of your own. I've made a video about it and I'll leave the link in the description. But let me also say, even though if you create your own VPN, you need to host it somewhere on the cloud. If you're hosting on Google Cloud Platform, for example, that means Google can monitor your VPN server activities because your VPN is hosted on their servers. So can you trust Google? Actually, can you really trust anyone with your data?